Okay, so what we're going to do here is build a circuit that will turn on this RGB LED when it's dark outside. Instead of having the LED on all the time and always consuming energy, and if it's a nightlight, you really don't need it to be on during the daytime. So this is a circuit that uses what's called a photocell. It's called a cadmium sulfide cell or a photocell. And this is a device that has a resistance that changes when light shines on it. And the important thing about it is it's a sensor that's capable of detecting light that shines on it. So with this circuit, what happens is when I cover up the light on there, you'll see that LED glows. And in addition to covering it up with my finger, I can also just turn off the light in the room. 1, 2, and you'll see that the LED turns on. So this is the circuit that we want to build, so that we have some smarts in our circuit so that the LED only turns on at nighttime. Okay, so now let's sort of step back a little bit, and then let me show you what the circuit diagram looks like. This is what we call the schematic for the circuit. The schematic is just an electronic drawing, sort of an engineering drawing of the circuit. Okay, and I'll put the actual circuit here if we can see it there. Well, let me back up a little. Okay. So let me try to illustrate now. So the first thing we have here is our battery, our 3-volt battery pack, and here we have that battery pack here. And notice that in the circuit we have all of these different components, and the battery pack has its plus terminal here. That's the red wire. That's connected up here to this line. We call that the 3-volt voltage rail. And on our breadboard, that's going to be connected up here, and everywhere down this line is our 3-volt rail. So there's connection inside the breadboard. There's a metal strip that runs in there. So anything that we plug in there will be connected to 3 volts. And then likewise, we have the negative polarity of the battery pack. That's the black wire. That's connected down here to what we call a negative or a ground rail, and that's just shown here. So in this manner, by connecting the red wire to the positive rail, the black wire to the negative rail, we can access our battery from all points along using those rails. Okay. We also have in here our photocell or a cadmium sulfide cell. This is the device that measures light. And the purpose of this whole circuit here is to provide a means for turning on or off our RGB LED. And I've got the RGB LED shown here. Now, in this case, the LED, I've got this built with only 2 resistors, whereas here I've shown it with 3. And, as you remember from experimenting before, you can choose what color you want by turning on different segments of the RGB LED. So if you turn them all on, it would glow white. And here I have the red and the blue turned on with some resistors, so it's going to cause it to glow in magenta. But you can choose the color that you want. Okay, let's continue looking at the components. You're going to find that sometimes you need to adjust the light sensitivity. Sometimes you might take it outside and it's a bright day and the thing is still maybe it's an overcasty day and it's turning on. So you have to make the device less sensitive. So there's what's called a variable resistor right here, and this is a tool that's used for adjusting that. And that's this right here. I'll show you what to do with that once we get it built. But the idea here is that we're going to have a voltage at this point that's going to depend on how much shine. It's going to turn on a transistor. And a transistor is a small device that I'll show you, which will, when that turn going to cause to. Okay. Let me start out here let me next show you all the parts that we're going to need in here. And what I'm going to do is I'm going to pull apart the breadboard here I've got and build it so that you can see how it's done. So we need the 3-volt battery pack. All right, that's this device. Okay. I need a 1 kilo variable. Now in your little pack that you've got in your kit, you'll find a variable resistor. That's this little device here. It's blue with sort of dial on it, and what that like. And back to our drawing here. I'm showing two terminals or two connections for that. I have one in the other, and if you look at this, it actually has 3 wires on it. It has 1, 2, and 3. What we need is the middle one in either of the ends, and I'll show you that once we hook it up. So that's our variable resistor. The trimmer tool, going down the list, this device that I have, you'll find one. A CDS cell or a photocell. That's our cadmium sulfide cell. We'll be giving you one of those in today's lab. Okay, that's the CDS cell. Okay, we're going to need 4 100 ohm resistors. Why 4? Well, we have one here, and then we have 100 ohm resistors here for our LEDs. So if I go back to the collection of wires that we have, the collection of resistors, the 100 ohm are the brown, black, brown. So I'm just going to pull out 4 of these. 1, 2, 3, 4. And remember, these are the brown, black, and brown. Okay, so those are our resistors. We need our RGB LED. And now you've been working with this RGB LED already. You did a previous experiment. If you're finding that the wires are bent too much and it's hard to work with, just come up and see someone from the teaching team and we'll get you another RGB LED. Okay, we need a small 2N3904 transistor. And here's a picture of what that looks like. Or that's not a picture, that's more of a cartoon. But it's inside your bag of parts. It's this little device here. Tiny little transistor. And you'll notice that it has a flat side on it, and then it has a round side. And when we put it into our circuit, there are 3 terminals on here. There's one called a base, one called a collector, and one called an emitter. And so if you put it on the ground, put it on the table so that the flat side is up, then those terminals are EBC, emitter, base, collector. And it's important to get these plugged in the right way when you plug it into the circuit. Okay, so we need a transistor. Oh, we need 3 or 4 wires. So here are some wires. Okay, and then of course we need our breadboard. So now I'm going to go and I'm just going to build this using all these parts. But let me run through the parts again because I did that kind of fast. So we have our 3-volt battery pack. That's here. We need this 100K. It's called a 100 kilo ohm variable resistor. We need our trimmer tool, the cadmium sulfide cell. We wanted 4 100 ohm resistors, the RGB LED, the small transistor, and then 3 or 4 wires, and our breadboard. So I'll sort of pause for a minute while you gather up those parts. I'm going to move all those parts kind of up to the top of the work area here so I can start building this. Okay. So first, just a bit about the alignment of the breadboard. The breadboard actually has a top and a bottom. And here I've got that red wire, which is plus on top, and I have a blue wire, which is minus on the bottom. If I spun it around, we'd have that reversed, right? So we do not want the blue on top. We want the red on top. Why is that? That's going to be our positive voltage rail. So if we go back and look at our schematic, you see that everything is powered by the 3-volt battery. And up on the top, we're showing the plus 3 volts. That's going to plug into this positive rail, which is red. And then on the bottom, we're going to have our minus 3 volts. That's the black wire, which will plug in down here. Okay, so I'm going to plug the battery in last. So the first thing I'm going to do is get this little device that says RVAR. And it's got 3 wires on it. I'm just going to plug it in somewhere on the breadboard. and you can see it's plugged in here. Okay, there are you can see where two of the pins are, and then the third pin is in the back. And what I need to make use of is the middle and then either of the two ends. So I'm going to take the middle and the rightmost end, and I'm going to connect it up as shown here. Okay, so the middle wire, I'm going to connect that to my positive rail. Now, to that other end, to this one right here, I have to connect that to this cadmium sulfide or photocell. And the other end of the photocell is going to go to ground. So I have this cell. It has pretty long wires. And I'm going to put one wire in there and the other one in there. Actually, I'm going to move this lead over a little bit, and you'll see why shortly. We're going to find later on that we have to use this trim tool to adjust this, and that's just a little. There's a little slot inside there. There's a slotted screwdriver, and you can put that in and turn it if we need to change the sensitivity of the device. Okay, so we have this part of this hooked up. The next thing I need is a 100 ohm resistor, and then we're going to go into the base of our transistor. And the base was the middle wire of the transistor. So I have my transistor. Oh, and by the way, these transistors actually have their part number printed on them. And what we're using is a 2N3904 transistor. And it's a little hard to show this on this video, but I'm going to shine some light on it and you should be able to see. Let's get closer. Well, I can't get it to focus with all the light, but that says 2N3904, and that identifies that transistor. But I've got the flat side up on top, so I'm just going to take that and put that in the breadboard. And I have to pull the wires apart a little bit, not much, just enough to fit them into 3 adjacent holes on the breadboard. So I'm just going to put them in 3 adjacent holes like this. Okay, so now I have the transistor in there, and I have to connect between this point here and the base with a 100 ohm resistor. So here's my 100 ohm resistor. And I have to go between this point. This is where the photocell is meeting up with that resistor, that variable resistor. So I'm going to put it in right here, right there. That's going to go into the base of the transistor, and the base of the transistor is the middle lead. So you look at the transistor. It has 3 leads. It's going to connect to that base. So I'm going to go from behind it. Plug that wire in right there. Okay? So we've now built this part, and I have the transistor, and I'm hooking that up. I have to connect the emitter to ground. And so I'm going to use a black wire. The emitter is the leftmost wire here. And so I'm going to put that black wire right in there, in that leftmost wire, and I'm going to connect that to my negative or ground rail. Now let me just say a little bit about wire colors and convention. A convention in electrical engineering is when you have something that's connected directly to your positive voltage rail, you use a red wire. Sometimes you could use an orange wire depending on, if you have enough red. And then when you're connecting something directly to ground, you use a black wire, or you can use a blue wire. But this way, when you're testing this, debugging this, if you're showing it to someone else, they'll immediately know, okay, I know what the purpose of this is. This is connecting part of the circuit to positive voltage, and this is connecting to negative voltage. So that's an important convention that we use. Okay, so we now have this part of the circuit built. We have to put our RGB LED in here. Okay, and here's that LED. Now, remember the RGB LED has 1 long wire and 3 short wires. Let's see if you can see that. See, 1 long and 3 short. So what you do is you bend the long one back a little bit, and the long wire is going to be this one here. Remember, this is a light emitting diode that has 3 separate LEDs inside it. It has a red one, a green one, and a blue one. And it has what's called a common cathode, and that's this long wire. So I'm just going to push this into the breadboard like that, and I just sort of found some space for it. And then what I have to do is connect the collector of the transistor to that long wire. So the collector to the transistor is the rightmost lead. So back to this picture, it's that rightmost lead there. I'm going to put another wire here. And what color wire? Just don't use red or black. That's all. You can use any other color than red or black. Because red or black, we reserve those when we're connecting directly to one of the battery terminals. So that's just going to connect to that long wire of the LED. Okay, now I have the other wires of the LED, and I have to connect those using resistors up to that positive voltage rail. That's for this stuff here. So I'm just going to hook up 2 of them. I won't hook up all 3. I'll just use resistors to, because I want this to glow. Let's see. I'm going to make it glow red and blue to get magenta. So there's one of them, and you can see it's hard to see it, but that little resistor is connecting via this column to one of the legs of that LED. And the other end of the resistor is going up to 5 volts. Okay, I put my other resistor here. Okay, so there's the circuit. It's now built, and what I have to do is hook up my battery pack to it. So I have my red wire and my black wire. I don't see it coming on. Let me cover up this photocell. Okay, it does turn on. So now I'm going to test it. I'm going to turn off some of the light in the room. Okay, and there it is. It's turning on for us. Now, what I could do if I needed to, I could use this trimmer tool and I could change the value of this resistor to change the sensitivity of this device. And so if I turn it, let's see what happens if I turn this all the way to the right. And then what's happening is the LED is coming on even in the presence of this bright light. So when I turn this to the right, it makes this circuit less sensitive, meaning that it'll turn on even if I have some bright light. If I turn it the other direction, now I'm turning it counterclockwise, you see that LED has gone off, and I have to really darken this to get it to turn on. So this is an adjustment that you may or may not need to make. Okay, I'm going to put this light back on, and that's our circuit.